Thank you. And don't worry, I'm not going to sing. Oh, that did not go well. That did not go well. I can do that sometimes. I just could not find the key last night. Hello. Thank you for having me. This has been fantastic. This is a lovely conference. Thank you very much for inviting me. And I would like to talk to you about programming's greatest mistakes, including me. Oh, the ego. You know, mistake, yes, one of the greatest, I don't know. I just want to say before we start, kind of a content, it's not a content warning. Okay, so content warning, I'm about to swear in English, like one of the bad words, but it's relevant to the plot, as they say, so I have to. What I'm not going to be talking about is any software snafus where people got hurt or died, because it's a light-hearted talk. I want us to have fun, and so we're not going to go there, so don't worry about that. The talk, I've done this a couple of times. I've done it at NDC. NDC like to put my talks up on YouTube, where they get paid 0.18 of a cent every time somebody views it, which means they owe me about $25,000. But the great thing about that is that people in the comments tell me I'm wrong, and so I get to go back into the slide deck and adjust the notes and everything. So thank you to all these YouTube people who have pointed out that I am an idiot. And I'd like to get started by talking about one of my own mistakes. I'm going to be mean about other people's mistakes, but I want to start talking about one of my own. So, in the 90s, I worked at a company. We made membership management software, an MMS system. And our software, you could create very complex queries over your membership database, and we would save them out as a MED file, M-E-D. I can't remember what that stands for, but MED is forever burned into my brain because of this. We released a new version of the software, and it corrupted people's MED files. And these queries had taken, in some cases, kind of days and days to get right. And we broke them. And this was before people kind of took backups or had Dropbox or anything like that. And so one of the support people came to me and went, Mark, the MED files are fucked. And I went, what? And he went, something's fucked up, the MED files. And I went, okay. And he went, here's an example of one of them that's been fucked up. Can you write something to fix it? And I went, yes, I can. We can reverse this. So you want me to write a MED file unfucker? And he went, yes, exactly. And so being young, seriously neurodivergent, and also, unknown to me at the time, but approaching a complete nervous breakdown / autistic meltdown, still not clear, I went into Visual Basic and I started a new project called Medfile Unfucker. And I wrote this thing, and it had a dialog box, and the title said Medfile Unfucker, and it had a text box and a button that said choose file to unfuck. And you clicked it and you chose the file, and then the button changed and it went unfucked now. And so you click that and it fixed it, and then it popped up just a little message saying medfile unfucked successfully. Okay. And so I thought, well, I should make sure that he tests it. So I went, can you test this on all the files that you've been sent so we can make sure it works in all of them? So I did, and then I heard no more about it until I got called into the managing director's office, because he had not only tested this piece of software, he'd released it to a customer who paid us £750,000 a year in support fees to be extremely professional people and basically not do shit like this. And he went, what were you thinking? And yeah, I was kind of like, well, it's not my fault, because he wasn't, obviously he shouldn't have released that. Didn't he read any of the words that were on the screen? But, you know, with the benefit of, I'm 50 years old now and I'm looking back at kind of 20-something me, yeah, I should probably not have put fuck into the code in the first place. So yeah. That didn't actually cost us very much. The customer kind of laughed it off and said, can you make sure that he's not allowed to do any more UX work and just works on back-end things. We don't really care if there's a database table called shit stuff. But, but yes. But so for the majority of the things in this talk, I'm going to talk about what happened and then how much it cost. Okay, so Y2K, who was around for Y2K? And I had to fix stuff. Anyone have to fix? Yeah, so a few of the older people. It drives me nuts now that people use Y2K as an example of when experts made a big fuss about something and then nothing happened. I mean, this came up with the whole sort of, in Brexit in the UK, oh, remember they said that about Y2K, and COVID, and all this sort of stuff. And the fact is that billions and billions of dollars and euros and pounds were spent to make sure that Y2K didn't crash the world, and we worked incredibly hard because, yeah, and we did a great job, and well done us. But no, everyone just goes, oh, well, that was a big fuss about nothing. But no, to understand why Y2K happened, though, you have to understand what computing looked like in the 1950s, and the fact that this is a punch card, and this is one line of Fortran code, or COBOL code, I'm not sure which, but it's one line of code on a punch card. And so the less stuff you had to type, the better, frankly. And this is memory. So this is core memory. This is what memory looked like in the late 50s and into the early 60s. This is hundreds of little pins, and through each pin, copper wire is run, 2 copper wires are running in a crossed formation. And this is about 16 bytes of RAM, I think, this chunk of core memory. This was actually knitted. It was made by hand. Women with kind of magnifying glasses and very steady hands actually passing needles through each of these pins. There was no automation at the time. So core memory cost about $1 a byte. And so you think you've got, what, 8 gigabytes of storage in your phone? So that would have been $8 billion. So yeah, memory was at a premium. And COBOL, I mean, a mistake in itself, obviously. But COBOL was not particularly memory efficient generally, and so they had to make savings where they could. And so COBOL's date type, WSTX date, was a PIC96, which means it's a character field with 6 characters. And so you could store the day and the month and the last 2 digits of the year, which in 1950, absolutely fine. This is Bob Beamer, and Bob Beamer in the late 50s was the guy who started to say, hey, this 2-digit date thing, I mean, yeah, okay, that's fine for now, but can we just, like, before any concept of Agile or Kanban or anything like that, he went, can we put a big red ticket in the backlog that we need to start fixing this probably somewhere around 1970? Because, you know, pension funds, for example, you put in the date that a person is expected to retire. And so even back then, that you couldn't put dates in the 20-somethings in the 21st century. And so Bob Beamer said this in 1959, and then he said it again in 1969, and then again in 1975, and again in 1980, and he was really starting to panic. In 1995, there was a big meeting of like the computer bosses, Microsoft and Oracle and IBM and all this sort of thing. And they went, yeah, we should probably do something about this, because software is now doing important things like flying airplanes and running hospitals and basically everything. And so I swear it was 1997 when I started getting contracts that were paying like double the previous rate. I learned to read COBOL so that I could translate it into Infomix 4GL, which was pretty much already a dead language at the time, but at least it had 4-digit dates. They estimate that fixing Y2K in total around the world cost $500 billion, $500 billion. Mainly because we left it all to the last moment, but also because in a lot of cases they just fixed it in COBOL systems, and you would not believe what COBOL programmers can charge by the day. There was a Y2K22 bug last year. Did anyone try and log into Office 365 Exchange last year and get this error from the webmail interface? Can't convert 2201010001 to long. So that obviously is the date, the 1st of January at 1 minute past midnight. It's fine as a string, but for some reason, somebody decided you could put that into a long, which you can't. It's too big. And so Microsoft actually had their own little Y2K bug last year. We have hopefully avoided the year 2038 bug, or the epocalypse, which is when the Unix 32-bit date overflows and stops being able to keep up with things. But this is my favorite one, the Kennel Club. If you have a pedigree dog in the UK, it is registered with the Kennel Club. I have a pedigree dog. I don't show it, I just call it Rosie and tell it it's ugly and stupid. But she is registered at the Kennel Club with her fancy show name, which I can't remember, but it's got Sugar Cookie in it somewhere. And these all go into a database, okay? And for each breed, you get the same name being used over and over again. And so they number the dogs. And so the first dog of like a soft-coated Wheaton Terrier called something something Sugar Cookie something will get the number 1. And then if somebody else comes along and they've given their dog the same name, it'll get the number 2. And this works fine until the 38th dog that is given the same name within the same breed. And then it can't store it, and it overflows. So can anyone have a quick guess as to how they're storing the number where everything up to number 37 would be fine, 38 overflows. But funnily enough, 39, that's fine. Roman numerals. They store the dog number as Roman numerals. And 38 in Roman numerals is XXX, V, III, and it's a 6-character field. And so 39 is XXXIX. And so, yeah, after you've gone past 38, you can go a fair bit longer, because then you get to like L instead of X. But yes, 38, it's not having it. So, yeah. Yeah. Who works in what you would consider to be an enterprise? Who works in a startup, but they're using like enterprise practices and all that sort of thing? Yeah, it's never done that before. So yeah, no, enterprise. A business plan or project, especially one that is difficult or that may fail or lose money. May, will. The majority of enterprise projects that I have been involved with, the company, IBM, Capgemini, Deloitte Touche, whoever it might be, Anderson's, they are more interested about covering themselves so that they are able to say, it's not our fault the project failed, than they are in trying to make sure the project doesn't fail. That is my experience. But enterprise, they watch what else is going on in the world of software, and then they adopt it, but they enterprise-ify. And they're not ashamed of doing this either. They go, oh, well, that's a great thing, but it's not enough for the enterprise. We need more process. We need more rigor. We need to be not sued when our projects go wrong, which they always do. And so, for example, enterprise look at the rest of the world and they go, oh, you're doing this agile thing like Scrum or extreme programming. That's very interesting. We should adopt that. And this is for lean enterprises. Yeah? This is the light version of the scaled agile framework for lean enterprises. Yeah, and they think this is, and the thing is, compared to like their waterfall processes, this fits on a slide. Prince 2 or SSADM, those you could go off to university and do a degree in either of those. But yeah, so this is the scaled agile framework for lean enterprises. This is Auto Scrum 1.1. I don't know what's going on there. This is Accenture. Don't ever. We have an Auto Scrum coordinator. We've got platform architects, system engineers. Down the bottom there's an agile team. Yeah, no, they really don't get much of a mention down there, the software developers. Look, if you can't see them, they're just there. There you go, that's shifting left, isn't it? Yes, why is that going to fail? But the thing that really terrifies me is this, where this and this are single dots on this map. So yeah, my favorite enterprise story is I was working for a company post-nervous breakdown, great company. We did Agile, we did Scrum, we did all that sort of stuff, pair programming, the whole thing. And I got sent up to an agency in the UK to find out why a web server they were running kept crashing. This would have been in 2012, 13? Yeah, 2013, 2014. And I went up there, and they gave me the code, and it was a .NET 2 solution running in 32-bit mode on an 8-year-old 32-bit web server with 4 gigs of RAM, but only configured to be able to use 3 gigs of it. Using an Oracle database. The Oracle database was up to date, at least. It was anonymous, open. If you knew the IP address, you could hit it. There was no throttling based on your incoming IP address. But the key thing really was that at no point, who's a .NET developer? So for those of you who are not .NET developers, in .NET we have this concept of things called disposable. So a disposable object is one that has created unmanaged resources like network connections, unmanaged memory, that sort of thing. And so when the object is collected, when it goes out of scope, it needs to close those connections or those files or release that memory. And so they implement an interface called iDisposable, and there's a shortcut in there, because this is such a common thing, where you can say using. So it's like goes defer. You can say using this, and then as soon as it goes out of scope, it calls the dispose method, and it shuts everything down. And the most important thing for this is database connections, because database connections create unmanaged memory and a network socket, and quite often a temporary file as well. And so this piece of software has about 30 places where it connects to the Oracle database, and in none of them does it dispose the connection after it's finished with it, which meant this thing was leaking memory at a rate that caused it to crash and recycle the IIS app pool about once every 40 minutes. Remember that 40 minutes, once every 40 minutes. People are just hitting it constantly. And they said, take this away and write us a report on how to fix it. So I took it away, I fixed it, and then I wrote a report telling them what I'd done. And just, while I was in there, I loaded it up into modern Visual Studio with ReSharper installed, and ReSharper burst into tears and uninstalled itself. And I had to use Visual Studio's built-in analysis. But yeah, I just fixed the whole thing. And so we delivered the report back to them along with the fixed solution. While I was in there, I upgraded it to the latest version of .NET, made it 64-bit, and we didn't hear anything back from them. We're like, that's cool, that was fixed. Until 6 months later, when I get invited to go up to this place to have a meeting with the stakeholders to discuss the content of my report. And so I go up with my boss in his Mercedes, and we sit down in this meeting. There are 6 senior IBM consultants. Oh, never mind. IBM consultants in this meeting, plus the head of the data center where operations currently are, the head of the data center where the operations are moving to, and 3 senior members of staff from the agency in question. So I'm looking at this and I'm going, this meeting is costing, what, £25,000 to have all these people here? I mean, I was costing them $1,500 for the day. My boss was costing them more like $2,500. So I thought 25,000, conservative estimate. And they went, so we're a bit concerned about your report. How can we verify that this is going to work? And I went, well, I also have the fixed version, and so you can just test it, and you'll see that it works. And we ran it. We've load tested it. We've done all this sort of stuff. The results are in the report. They went, yes, but this is critical, business-critical software. And I'm like, it's business-critical software that crashes every 40 minutes. It's terrible. And it really wasn't a complicated fix. Trust me, this will fix it. And if you don't want this completely fixed version, then just put those using statements in. It will run fine. And this just went, they allocated the entire day to ask me about this. And they said, and this other thing where you're saying we should update to a newer version of .NET, buy a new server, and run it in 64-bit mode so that we can access more memory. And I'm kind of like, well, yeah, I mean, that just that goes without saying. Everything these days should be on the latest version of .NET, and it should be running in 64-bit mode. And they just kept pushing back and pushing back and pushing back. And I smoked at the time, and I had not had a cigarette for a while. And I eventually went, look, for what we are spending just to have this meeting, I could buy an entire rack full of servers and just offset them from each other so that the 40-minute crash didn't happen at the same time on all of them, and that would fix the problem as well. And my boss went, Mark, why don't you go outside and get some air? And I went, oh no, I'm fired again. And so I went outside, and he came out about 5 minutes later. And I was like, Dan, I'm really, really, really sorry. And he went, no. I told them to go fuck themselves. We don't need that shit. So yeah, I don't know what all these enterprise nonsenses have cost us over the years, but it is probably trillions of dollars. Okay, I'm going to bang through some fairly quickly because limited time, lots to get through today. I'm really looking forward to watching these talks myself. The Pentium FPU, this was an interest. So this was technically a software error, but it was a software error that then got carved into silicon and shipped in computers. The Pentium floating point unit, the Pentium was the first processor that came where all of them had the floating point unit built in. So the 486, you could buy the 486DX, which had the floating point unit, but the Pentium was the first one where they all had the floating point unit built in. So quickly, show of hands, what's 4,195,835 divided by 3,145,727? No, too slow. It is 1.33382. except according to the Intel Pentium's floating point unit, it was 1.33374. Now, you might think, that's not that much of an issue. Bear in mind that there are businesses in the world where their entire business model is making trades and shaving off those last couple of decimal places there, and that's where their profits come from. More on them later. Intel originally said, if you can prove that this is causing you a problem, because it's really not. If you're using this to run Quake 2, then you've maybe got something that's less than a pixel too far to the left sometimes. But they went, if you can prove it's actually causing you a problem, we will send you a replacement. It ended up with, look, just send it back and we'll send you a replacement, and it cost them $475 million in a recall. That was fun. Null? Oh, you know how much this cost, because Anthony Hoare, who is the guy who very graciously and grown-uply accepted responsibility for null, has called it his billion-dollar mistake. But he was creating Algol W, which was kind of Algol with records. And so you had a record, which was a person, and this was the first programming language where you had this concept of structs or records, and so you had references to other structs or records. So when you had strings and integers and logicals, if there was nothing in the string, then it was just a zero-length string. It wasn't null, it was empty. If there was nothing in integer, it was zero. If there was nothing in logical, it was false. But if there was nothing in reference, what do you call that? What do you call it when there's... So he's saying, well, we'll call it a reference to nothing. But let's just say that's null. And so it was a reference to a memory address that was specifically known to be to mean nothing. And so they used the keyword null to check for that, and invented a whole class of errors that plagues us to this day. So yes, $1 billion. The Hartford Center, this is an interesting example. So the Hartford Center is in Connecticut in the United States, and it was one of the first buildings that was designed using computer-aided design and computer-assisted engineering. And this was back in the days, it wasn't like AutoCAD now, where it's a lovely graphical user interface and you sort of draw lines and do this sort of thing. You actually programmed in sort of the material and the tensile strength and the shear strength of various things, and it would do the calculations and tell you how many rivets you needed and what kind of welding should be used and all that sort of thing. And somebody programmed in all the stuff for the Hartford Center, and they accounted for the weight. So it snows a lot in Connecticut, the northeastern United States. It snows a lot in the winter. And so they went, well, it's going to snow, and so we're going to get a buildup of snow on the roof, and so we need to account for that strength. So they accounted for that. What they didn't account for is the fact that when the snow starts to melt, it moves sideways, and so you also get shear strength. And so this is what happened to the Hartford Center because somebody didn't account for the shear in their software. Fortunately, nobody was in there at the time, don't worry, not even a security person or the cleaners. It was completely empty, but it cost $90 million to put a new roof on it. So that was fun. Knight Capital, let's talk about somebody who bloody deserved it. So, the first stock exchange was actually just up the road in Amsterdam. It was the Dutch East India Trading Company who had discovered India and needed to build as many ships as they could so that they could go to India and steal their stuff and bring it back and sell it. Ethics aside, they came up with the idea of saying, okay, we will sell you a share in the Dutch East India Company, and then when we make profits, we will give you that share of the profits, and so you can make lots of money like this, which was a really good way of like bootstrapping a company. By the early 2000s, what that had become is we will write highly optimized pieces of autonomous software that will run entirely without control and will make micro trades in fractions of a second so that we can cream fractions of a cent off the economy and give it to the richest people in the world. This is how the stock market works now. It serves nobody except people who own stock and the people who do their trading for them, mainly the people who do their trading for them. Knight Capital, so around the millennium, when they kind of went over to digital trading and all this sort of stuff, there were what's known as dark pools. These were just servers that were run as close as possible to the stock exchange, usually the New York Stock Exchange, because the latency was super important, and they would just deploy autonomous code into there to try and make trades as quickly as possible. And lots of these dark pools were popping up, and they were unregulated, and the SEC couldn't regulate them. And so the New York Stock Exchange went, well, to put a stop to this, we will create official light pools actually inside the stock exchange, and then companies can pay us to host their software in there. And so they created this, and they created the protocol to do the trading. And the companies had 6 weeks to update their software, to work with these new protocols, and to get it live in the New York Stock Exchange. Knight Capital, they managed this. They repurposed a lot of their existing code, and on the morning of, excuse me, I have to check my notes here. And it's not in my notes. Anyway, on the morning that it went live, they put their software in there. And half an hour later, it had spent billions of dollars. And they went, oh no, what's happened? And so they went and they looked, and they saw that one of the nodes, they were running on 8 nodes, and they saw that one of the nodes had not updated correctly. And so they went, oh, we need to roll out to that node. What had actually happened was that 7 of the nodes had updated to the new software, which was broken, and the one node that was left over was the only one that was not absolutely broken. And yes, and so once they fixed that last node, it started to spend money at an even more ridiculous rate. What had happened was they'd copied and pasted a bunch of code, and like I said, this is highly optimized code. So they've got lots of bytes where they're using them as bit masks, and rewriting it so that one of the bits in a bit mask means something different, or adding a new one, trying to find somewhere you can put a bit. And so they just repurposed a bit in one of the existing bytes, except there was still code in there that looked at that byte and that bit and thought it meant the old thing, which was to peg the trading, to say, do not buy more than $100 million worth of any share ever, because you're not allowed to do that, or $10 million worth, or whatever it was. The new software set that bit to 0, and so the software just went, I can spend all the money! And it did. By the time they finally shut it down at about midday, it had spent 4.5, it's either 4.5 billion, 45 billion, or $450 billion. Whatever it was, Knight Capital was supposed to have paid it by 5 o'clock that afternoon, which they absolutely could not do. And you can't go to the New York Stock Exchange and say, sorry, Mulligan, golf thing, can I have a do-over? So they ended up having to be bought out by a much larger concern. And it ended up costing them $440 million at the end of the day. It bankrupted Knight Capital, and they were folded shortly afterwards. Bugs in space. So yes. Mariner 1. So Mariner 1 was a mission to Venus by NASA, and this is what Mariner 1 should have looked like as it majestically sailed off to Venus to go and explore the atmosphere. But this wasn't actually a programmer error. The programmer did what they were supposed to do. The person who wrote the spec for the programmer missed something out. So on the left, we have bar.rn, which is the value of .rn, but smoothed over time. So take the average of the current value and the last, whatever it is, values that you use for smoothing. The one on the right just means the value of .rn at this instant in time. So the hyphen is kind of important, and the person who wrote the spec in Pen for the developer to code in Fortran didn't put in the hyphen. And so Mariner 1, the software, was looking at the instantaneous value of this instead of the smoothed value. And so when Mariner 1 took off, and the guidance computer was checking to see that the thrust vector was within parameters. And the thrust vector, when you're burning fuel, that's what you're actually doing is generating thousands of explosions every second. And if you slow it right down, you can see it go. And so that R number, which is thrust, does go like this. It bounces up and down. And so if the guidance computer sees it doing this, it goes, oh no, something's in terrible trouble. And so it sent a message back to mission control going, something's gone terribly wrong. And the mission controller just hit the big red button and blew Mariner up 5 minutes into its flight at a cost of $18 million in then money in 1960. And actually, that is the incident that caused software engineering to be proposed as a discipline. You go, let's start building software a bit more carefully and pretend that we're professionals at this and have like computer science degrees and things. The Mars Climate Orbiter, this is a brilliant one. This is what the Mars Climate Orbiter should have looked like. Artist's impression. So, Mars Climate Orbiter, typical American problem. So these are centimeters. Americans don't know what these are. Well, no, to be fair, NASA know what centimeters and meters and millimeters are, but Lockheed Aviation apparently don't. So, that's kind of the difference between centimeters. So the guy on the left is 70 centimeters tall, and the guy on the right is 70 inches tall. So Lockheed Martin, who did the avionics that was supposed to put the Mars Climate Orbiter into orbit around Mars, and what they thought was the trajectory would have put it into orbit at a height of 226 kilometers, which is a nice orbit, but what it actually did was put it into orbit at a height of 57 kilometers, which is also known as a crash dive path. And so that's what happened. This happened much later, much more recently, $327 million. NASA very nicely and sweetly don't blame Lockheed Martin, but everybody else does. Ariane 5, this was quite similar to the Night Capital thing. This was copying and pasting code. So the European Space Agency, they're not good at getting the Arianes to launch at time. When's Ariane 6 launching? That was like last year or the year before. Oh no, hang on, it's next year, hopefully, maybe. So Ariane 5 was also running late, but they had this big, here's the initial launch from French Guinea, and they had lots of dignitaries coming to see it and so forth, but they had copied and pasted a bunch of code from the Ariane 4 thing. And of course, Ariane 4's guidance software was written in 16-bit code. Ariane 5's was written in 32-bit code, which meant that their integers were a different size, which meant that a thing overflowed an integer, and that happened. Has anyone ever done an integer overflow that actually blew up something like that? I haven't, but that would be awesome to have that on your CV. $500 million. The big rewrite, this was basically, I got halfway through a project, Microsoft released, I was doing it in Windows Forms, Microsoft released WPF, I went, ooh, let's rewrite it in WPF. That's what caused my nervous breakdown. So about £100,000 and my sanity. And then finally, JavaScript. So it's not that JavaScript is in itself a mistake, but, well, so as Dylan was showing last night, you can do things like this. And then, of course, you can do B plus A plus plus A plus A, which obviously is banana, because A plus plus A causes nan to go into the middle of the string there. And so JavaScript, you can do great things with JavaScript, but what I'd really like to do is get in a time machine, go back to 1995, grab Brendan Ike, and go, hey, they're going to ask you to knock together a tech demo for later. They're going to come to you. They're going to give you about a week. Can you please start now? And just spend a year on it, because one day this thing's going to be running on spaceships. So yes, there's some more examples there. Honorable mentions, Heartbleed, Log4j, Java XDSA. Finally, just very quickly, the Soviet early warning system. So this is Lieutenant Colonel Stanislav Petrov. And on September the 26th, 1983, the Russian early warning computers said, hey, missiles incoming from the United States. And Lieutenant Colonel Petrov went, that's probably a glitch. It was the computer misidentifying sunlight glinting off clouds as the incoming apocalypse. And so he elected not to fire the retaliatory missiles, and we didn't all die. So thank you, Lieutenant Colonel Petrov, and thank you, Joy of Coding. I will hope you enjoy the rest of your day. Thank you.